Ni hao, hello. I'm very thankful to be invited to participate in this conference, China RubyConf 2025, and I'm also thankful that I'm allowed to present the talk in English. The title of the talk is it possible to use Ruby for game dev? My name is Pavel Oganesyan, and I'm an assistant professor at MSU BIT University in Shenzhen, China, and also a professor in Southern Federal University in Rostov-on-Don, Russia. I've been a professional developer since 2011, and I also have been working in academia. Currently, I'm teaching some courses related to Ruby and web development using Rails, of course, and also related to game development. And I also worked as a producer in Game Dev Studio and currently working on some indie games. So the outline of the talk is presented on this slide, and I would like to start with the motivation for the talk. So first of all, we know that majority of Ruby developers are actually Rails developers. So we are mostly working with one specific framework, which is a very good one, but Ruby can do a lot of other things. That's very powerful, very flexible language, and we have a lot of nice gems like Dragon Ruby, which is not a gem but a game engine, like Ronin, Discord RB, and other projects that are not completely related to the web. And I also believe that a lot of professional developers love to play video games, and a lot of professional developers would like to build some interactive stuff as a hobby and games as a hobby, maybe even if it is not the first source of income for them. I have to notice that there was a talk at RubyConf 2022 presented by Amir Rajan, who is the author of Dragon Ruby, and it was a talk like from the creator of an engine. There also was my talk as a user of an engine on Ruby Russia Conference 2023, but my talk was in Russian and it's not translated, so I will give an extended version of this talk now. And I would like to start this current landscape of game engines. So first of all, we have two major players. You all know them. That's Unreal Engine and Unity Engine, and they like dominating the whole market. And we expect and analytics expect that the market share in terms of game engines will only grow over years because it is very, very expensive to maintain your own game engine for a big web studio. And if you want to use an open source or free frameworks and engines, you also have some choices like Godot, for example, and other small engines or somewhat small engines because Godot is now quite big. And the landscape of the engines is reflected in the landscape of the languages being used in game dev. The king here is C++, which is used in Unreal Engine in the majority of homegrown engines in different studios. Then you have C#, which is a little bit more friendly, and it also used in a lot of tools like Godot and Unity. And you have Lua, which is a very popular scripting tool in game dev, but it's also statically typed. And we also have JavaScript, which is mainly used as a language for web games or playable ads. It has some nice libraries. We have some aspiring languages like Verse, which was developed by Epic Games and Haskell's creator Simon Peyton-Jones not too many years ago. Very recent, very new language, specifically designed to be used for building metaverses. And I will not discuss if metaverses are already dead or if they not dead yet, but still we have a new language for them. And bad news, no Ruby in this landscape for now, but we still have some like tools, and to start talking about these tools, we need to bring in some definitions. So let's start with the definition of game engine. So game engine is basically a software development pattern, and it can be stated as following on the slide. So it is an infinite loop. It processes user input, it updates the game state, it renders the game, and it controls the rate of gameplay. The first games, like text-based games were very easy, and they allowed us to use blocking input. So the code sample here is very simple, like input equals read input, we call a function and we wait until user provides something. But if you want an interactive game, you split your game loop into 3 parts, you process input asynchronously, non-blockingly, then you update the state, and then you render the new state of your game. And the state of your game is basically a set of variables, and in this case, in this traditionally written code sample, there is a huge question like where is the state? In our usual web applications, the state in the database, and the rest, the approach that we are all using says that there is no state, like, yeah, stateless. Nothing happens between the requests. That is not completely true, but still. But in games, it's not like that. The state is always there and it should be stored somewhere. And we'll get back to this question a little bit later. Now, when we have our main idea, we can make a list, like what do we want from a framework that would call itself a game engine. So we have some essential requirements like rendering, user inputs and physics, and analytical geometry tools, like you need classes for vectors, for shapes, for collision detections, for numerical integration to get correct physical simulations, and so on and so on. And then there is a list of nice to have things like sound tooling, visual effects, animation tooling, and so on and so on. And then important thing here is to talk about debug and live reload, because then you test your applications. In web you can make a request, and request provides all the needed information usually. So you make some stuff in the database, then you throw in the correct request and you see what happens. But in games you cannot do that. There is no request. There is a game which was run and it is in some state, and you want to change something and see what happens. And if you don't have live reload, you have to do all the stuff that led you to this state. So possibility to change a variable or a class or something, a function, during the execution of your game is very important and very nice to have. And now I would like to talk about Dragon Ruby, which is commercial game engine. Commercial means that you have to pay for that, but it is royalty free, so you don't have to share profit from your game, which is not the case for Unity and Unreal. It is written in Ruby, and it is using in Ruby and C, and it uses the library which is called SDL, and this library allows engine to do very performant, very efficient rendering. As usual, like if Ruby is not fast enough, you use C. It is 2D engine. There is no intention to use it for 3D games, and it uses mRuby. The mRuby is another version of our favorite language. So C Ruby is reference implementation. We all worked using C Ruby with Rails, and then Ruby is embedded, very lightweight version, also created by Yukihiro Matsumoto, and it targets Internet of Things, embedded systems, and game scripting, while C Ruby targets servers and applications mostly. mRuby is also MIT licensed. And nice thing here that it allows you to build a single binary that will have your application and Ruby in it, so you will not be required to provide your game and sources, which is also a nice thing to have. It also allows you to do ultra low memory usage, and it allows you to do static allocation if it is possible, and you just provide compiled binary, unlike in usual Ruby. But the downside here that it has some limitations. So all benefits, like they have other side of the medal. mRuby is a little bit more safe because it has no eval or no dynamic code loading, so it does not have such huge possibilities in reflection, for example, like C Ruby has. But it is truly cross-platform because you don't need an interpreter. You just compile for different platforms, and in case of Dragon Ruby, it is very easy to do. And it can be run in web using WebAssembly, on mobiles, on Windows, on Linux, on consoles, and so on, so on, so on. But now let's speak about what is so specific about Ruby in game development. Let's go back to game loop. I don't want to talk about input processing, because usually you just have a set of classes in game engine that gives you the input from the player. I also don't want to talk about rendering, because rendering is usually a task for game engine developer. If I would like to develop an engine, that would be my problem. If I would like to use an engine, that usually is not my problem. So our problem as game developers is usually to write a correct update. And I would like to talk about this, starting with tiny code sample. Def tick, so we define a function tick, it takes arguments, and all logic of your game in Dragon Ruby goes here. So that's it. That's our part of game loop in Dragon Ruby. In this part, we can write our code, and now we have state. So state is stored somewhere in our variable args. It is like a huge hash of data, or an object that looks like hash. We are back to our usual dynamically typed language, and it stores your data. You also have outputs, and outputs are responsible for rendering. So everything you put into the outputs will be rendered. That's it. Like, very nice, very easy to understand API. But of course, we understand that if you build a real game, that would be not enough. So let's discuss what else we have. First of all, now we need to understand that this tick function will be called on every frame. And now we have to compute our frames per second. If we want to run at 60 FPS, which is quite reasonable, we have only 16.6 milliseconds per frame. And on different PCs or mobiles or browsers, doesn't matter, you will have different computation speed. And engines here come with some solutions, like what if we provide the delta time, like what time was when we last executed our last update. Or maybe we can run in fixed FPS. And here Dragon Ruby uses what we have in Rails. We have our convention of a configuration, and it says we will run all our 2D games in 60 FPS. And then we go and we try to see, like, how can we use our Rails core principle convention of a configuration in game development, like in other areas of expertise. And yes, it can be done here. It can be used here. So first of all, when you build a new project using Dragon Ruby, you have your folder structure as in Rails. You have your application, you have your data, you have your fonts and sounds and sprites all nicely packed in folders. And the application knows this file structure as it does in Rails, like it knows where views are and knows where controllers are, and here it knows where sprites are and so on. Then you have your code samples, like the game engine is provided as a huge amount of code samples, and each sample is a small game or game mechanic, like small part of the game, in sources. So you can see how mouse works here, how saving and loading works here, and so on and so on. And then you have only these two variables, like properties of args, state and outputs, and all you have to do is modify your state and outputs. And now I would like to compare some approaches that we have in other languages and other engines to Ruby. So what I will do, we will try to build a very small example, only in code. I will not be showing any pictures because I don't have enough time for that. But I want to build a system for a game where a player can move, and the player has an inventory, and in his inventory he has position and a sword, two different objects. And I want to update the player's position and the state of his items in the inventory, like what happens to sword and what happens to position, something like that, in three different manners. The first choice would be object-oriented programming, like the most dominant paradigm for now, which is used in Unity and Unreal, and we will go with this Unity for examples just to make it clear. This approach is based, as it can be expected from object-oriented programming, on inheritance and composition. And that means that we'll be working with classes. Classes can be inherited, or they can be used as properties of other classes to get a composition. And all classes will have a basic class, mono behavior, that will be responsible for providing callbacks for update, for doing stuff with your game objects. And that is the most common approach. So let's write something. I will be using C#, and my player will be obviously a class. It will be a descendant of mono behavior. It will have a position, and it will have list of items. Each item will be updated in the cycle. So this approach combines inheritance here, and we have like a container, which is a player, and inside of this container we store his inventory. We move the player in our update function that will be called by engine. We use delta time to make sure that we are aware of amount of time that has passed since last run, and we do the same update for each item in his inventory. So now we have to go and write abstract class item, maybe write some basic update logic. Then we have to go and override it in other classes, and then we have to go and provide some data, like what amount of health will be restored by health potion, and what is the damage of the sword, and so on and so on. So usual OOP, we combine our data and our logic inside of classes. That's how it's done in Unity. So after that, if you're not happy with this basic object-oriented programming, you can go to entity component system pass. That is a little bit more modern approach, which says like it is hard to make right abstractions using usual object-oriented programming, as we are aware of, and it would be better to use something else. What if we split all our game into 3 different parts? We will have entities, which are unique identifiers. So usually they are integers or lightweight structure that represents an object, a thing in your game. Then you have a component, which is pure data container, no methods, like looks like a struct to me. And then you have a system that is a logic. So you separate your data in logic into 2 different parts. It is also present in Unity using modern versions of Unity in Burst compiler. You can use entity component system, and code here now looks a little bit different. So first of all, you need your components. So you provide structs for players. Player tag will be helping us to identify the player. Position will be storing his actual position, and then you will have his inventory, and inside of the inventory we will be storing his items, and so on, so on, so on. Then our systems, for example, movement system, will be dealing with just the position of the player, and it is written like reduced on the slide because it would be too long to show the whole code sample. I will be showing only update for movement system. But you can expect that you need to write the same updates for all other systems, like the same update for inventory, and then maybe updates for each item. And then you have your entities that would be a struct that helps you to take different components, like take player tag, take player's position, take inventory, and merge it into a single entity. So actually, your data will be stored in some arrays, and your entity will be able to tell the engine which components are related to each other in a single entity. So this approach allows you to have a little bit better scalability, to make a little bit more performant code. But it requires you to write a lot of boilerplate. So the program becomes longer, and now you have to maintain a little bit more complicated interconnections between stuff in your game. And then what do we have in Dragon Ruby? And here we have dynamically typed interpreted language. So we are back to like the land that we love, to dynamically type Ruby. And that means that we can now use classes or hashes or arrays or any other stuff that provides needed information. And since it is interpreted, we have live reload out of the box without any extra tooling. Like, you don't have to do anything to get live reload in Ruby as usual. You also don't have to write any boilerplate code. Why? Because dynamically typed language, you don't need your structs. You may write them if you want to. You may use RBS if you want to, or sorbet, or any other tooling that allows you to add types, or at least like documenting types, these magic comments. But you are not required to do that. And since you're using embedded Ruby, there is no extra allocations, because when I was creating objects in my OOP implementation, object-oriented one, I was creating instances again and again. And here I will store the data like I did in ECS, but I will not be creating any instances if I don't want to. I will take the data out of that and I will just send the data to the update function. So let's see. First of all, I initialize my state, and if the game is small, we can do it in the same function. So here we just do aux.state.player o equals, so it will be initialized only one. We provide information about the player as a hash about inventory is array of objects. We do not have base class here, we do not have nothing. Then we handle the movement, then we update the inventory, and we render the player. So I will provide a couple of functions here for details, like update the inventory will be very easy function to write and understand. We take an item, we do the common logic, like we update the cooldown, then we do case item type, and if it is position, we do something for the position. If it is sort, we do something for the sort. Like that is it actually. And then the same goes for movement update and all the other stuff. So if we go to comparison, we see that Dragon Ruby provides you live reload because it uses mRuby, or any other Ruby would do the same. It will not help you with architecture. Only Entity Component System will provide built-in architecture for you. If you do object-oriented stuff, or you do any other stuff, architecture is up to you, but that is the interesting part. And the state here is just stored in global arrays, which allows you to get it faster. And no boilerplate code, which is good. Now we have a lot of flexibility. If you want to draw some squares, for example, you can provide them as an array, which is a position, width, and height. Then you can provide it with a color, different color, opacity, or the name of the sprite if it is sprite and not just the square. So this is the simplest approach, but it is not very readable. So if you want to see more details on the screen, you can take this position. They are not now looking like random numbers because they are sitting in the hash. Nice thing to have. Then if it is not enough, you can write your own classes. So you can write a class which will provide attribute accessors with the same names as fields of previous hash. Now you can do all other properties. You can do methods here, like an object-oriented approach. You can do what you want. If your class provides this data, now you can do your inheritance, you can do your composition up to you, and you can push it to game engine outputs because it will be able to extract data using attribute accessors. So now the level of difficulty is up to you. Plain arrays, just hashes, or full-scale object-oriented stuff. And in terms of speed of execution, there is very small difference. Like arrays are the fastest, classes are the slowest, but still the difference is not very much. After that, engine also provides some extra stuff. For example, we know what omakase is in Ruby and Rails when you have all the choices done for you for common problems. And in Dragon Ruby, we have this configuration. You say what's your name, what's the name of your game, what is your version, and so on, and then you do publish, and you get your binaries for different platforms, for PC, for web. Some versions of the engine, paid version, allows you to push to Steam or to mobile platforms semi-automatically, or push to itch.io and other sites these games. So like building the game is done in this omakase style. And then the hot topic, and we are almost at the end of the talk, AI. In the program of the conference, I've seen that the majority of talks, like many of talks, were about AI. And in games, we also love to use AI. And it actually helps small engines more than it helps large engines. Why? Because large engines have this, which is a lot of visual scripting tools. This is an animation controller in Unity. And AI, if you ask to help this animation controller, it will give you steps. Like click this, click that, oh, I do not understand what you have there, and so on, so on. But if you use a small engine like Dragon Ruby, you just do this, you use Copilot or any other stuff, and you say, help me write me a class, and it just writes you a class, because everything is done in plain code. So it is very easy to use generative AI for code if you are using small game engines. So the last part here. Yes, of course, it is possible to use Ruby. That was a bait question, actually, for game development. Ruby has its own usual advantages, flexibility, and very nice syntax. Ruby helps us to build it for all platforms. The speed of rendering is provided as usual by C and libraries written in it. We don't have too many tools, but some are already here, and AI helps to reduce the gap in tooling between small engines and large engines. So thank you for watching the talk. I encourage you to build games. If you have some questions or topics to discuss, write me a letter. I will be glad to talk about Ruby or game development with any fellow Rubyists. Have a nice conference. Thank you so much. Bye.